and my colleagues will take a look at them, or I will take a look at it in a little moment when I have gone through this why use version control. So this is the first actual lecture or whatever, because now we are through the setup. And I will talk a little bit about why you would actually want to use version control. So what is version control? Well, the definition from Wikipedia says that in software engineering, version control, or called revision control, source control, or source code management, is a class of systems responsible for managing changes to computer programs, documents, large websites, or other collections of information. So that is the official definition. And a version control system, you will find it's very often shortened to VCS, and it's a system responsible for managing changes. Why would you use it? I mean, let's assume you had an ideal world and you were writing something like a document, a some software, or maybe just you could also use it for your paper or whatever. And you would have the improvements you did Monday, you did improvements Tuesday, you did improvements Wednesday. And it all looks fine, it's linear, there's no problems, you don't backtrack anything, and you always know what everyone else is doing. And at the end, you simply have things done. Of course, everyone knows this is not how the world works. You did something good on Monday, but what you worked on Tuesday, you were tired, you didn't get your coffee or whatever. You simply did something that you would rather forget to your code and it's just wrong. So you spent Wednesday doing corrections instead. And because when you have a new version, maybe for your software, or you just made some changes, maybe it was really great, or maybe just delete all of it and you want to go back to what you did before. And your colleague, he is also working on something, and the other colleague over there, she's also doing something, and you haven't actually checked in with what they are doing. So you're all sitting there working together, but in your own way. And you still want to end up with a functional stuff in the end. So how is that easy to do? Sometimes maybe you simply want to go back to what you had before, just delete all of it. And sometimes it might be that you only want to change parts of it. But where is this earlier version of your code, for instance? Well, if you're in an editor, maybe you can use Control Z. Or maybe you named it something, maybe you called it my file text old or something, or maybe you have created a directory for each day's changes, which would be actually very organized and whatever. I mean, I would not be that organized. I would just have it in a mess. Or you could have a daily home directory backup, and that would also be good. But again, there are challenges and obstacles to this because you can make mistakes. Maybe you didn't make a new directory for today. Maybe you worked on it in yesterday's directory. Maybe you have saved it. You cannot go back and change it. I mean, there are limits. It can be overwritten. There are errors. How much should you also save? Should you simply make a copy of everything in your whole code, or only of individual files? And it can take up a lot of space also. And how do you even organize it? And what is the difference between the different versions? Because you also need to know which one to go back to. So it's not so easy to manage. And also, what granularity do you want to use? Because you would prefer only to fix the actual errors and not have to delete also a large chunk of a code you have written. So many problems. And hopefully version control systems can solve this. at least somewhat, because it will store the history using snapshots, which we call commits. And each of these snapshots represent the project at a given point in time. And the version control system will manage the snapshots and the associated metadata. It will do so with names, tags, for instance. You can put tags there. You can have you have comments, you have dates, authors, and other things to help you backtrack and find out who actually did something and when you did it and what it was. And that makes it fairly easy to move between different snapshots. And you can handle different degrees of granularity. And you can also have different branches for multiple development paths. So you can compare different snapshots, different commits. You can do that with, you have named revisions, comments, time information, author information. All of that will help you to compare the different snapshots. And there is, of course, diff tools to help you as well. There are search tools. And you can do a bisection search and try and look, go back and see, oh, these are the commits from last Wednesday. And you can see, okay, that is definitely before I made the change. And then you go forward and check there. Had I made the change here? Things like this. And version control systems also allows joining or merging of different snapshots. And it's easy to experiment with ideas by doing branches, for instance. And it's good for collaboration. And that is actually one of the primary functions or reasons why you have version control system, is to allow collaboration in a more organized way. So the normal setup is that you have a server, which would be remote. It could even be on, you don't need to use GitHub or GitLab or whatever. You could have a Git server set up in your own organization, and then all of you are working with that one from your own clients. So there are multiple clients. So you work locally and you send, that is called push, the changes to the server. And the version control system will keep track of what has been done and by whom. And this makes things safer because the mistakes can be remedied because you now have a backup of things and when it happened, and things like this. And several people contribute and you can merge it later. Of course, all of this only works if you are somewhat organized and remember to push changes regularly. And the version control system also functions as a backup in this way. So, and you maintain a copy of each file locally, and only the changes or the files that are changed are stored. So that means that it is less space than it would be if you actually backed up everything every time you change something. And globally, you can recover lost files from the server. If you have deleted the stuff on your own machine, it's no worry because you can just pull a new copy. And version control systems like Git, it's integrated with several services. There's like HapGangD, and Overleaf is also very useful if you want to do collaboration, because then you would have a somewhat graphical interface where you can sit and work on Git together with your collaborators. And you have services like GitHub, where you can see history, and it can also distribute it to your co-workers or to every other person in the world if you make it public. It's good for testing. There are bug reports, milestones, and there's a website you can create through GitHub also for it. So if you sum it all up, version control systems keep tracks of your files and other output. It tracks what is created and modified. It tracks who made the modifications, why the modifications were made, and well, if you make good commit comments. And that is something that needs to be stressed. Please make good commit comments so you can actually use them. So what are use cases for version control systems? Well, it could be source code. That is very common. And many version control systems are designed for managing source code and for managing the deployment, for production, development, testing, etc. It would be very common to have different branches for that, for instance. And you can manage published versions, like, and experimental features. And you can use it for bug hunting. But it's not just for source code, it's also for writers, artists, composers. Anything you have different versions of, you can put there, like your article, the tech files. You can track versions of a manuscript when it's submitted, revised, accepted, and you can collaborate with several authors. And Git is quite good at that, and so is other version control systems. You can use it for your batch files and for your data in HPC computing. You can track different versions of your batch scripts, and then you can use it to check what configuration did I use at that point, because you can just go back and look at it. You can use it to track input and output files, as long as it's not too big, of course, because it's not good for huge files. And version control systems, I have some examples here for you. There is the very first one, was called SCCS. It was created in 1972 at Bell Labs. And it only worked for source codes, and it only worked on Unix. Then came RCS, which I think is still around some places, Revision Control System. That is from July 1985. And usually it's later superseded by systems like CVS, which was originally a wrapper on top of RCS, the Revision Control System. The CVS is called the Centralized Version Control System. It's from July 1986, based on RCS. And it now adds support for repository level change tracking and client server models. So that is a step in the right direction. And then you have Apache Subversion SVN from 2004. And that was made to replace CVS by the CVS developers. Then came BitKeeper in May 2000. That was a distributed version control system, and it was used by Linus Torvalds to develop the Linux kernel. It then became proprietary and is no longer maintained. And then Linus Torvalds decided to make Git for the development of the Linux kernel. And that was in April 2005. And it's a distributed version control, and it's open source. So